Hey, Bruce here, Modern DriveLine. We have some quick tips for you today, and what we're doing is we're underneath a 66 Mustang with a 289 or a 302. I think in this case it's probably a 5-liter engine. And some of the things that we commonly get asked in the shop is the different flywheels, some of the pilots versus bearing, when I should grease, when I shouldn't grease, bolt patterns. How do I identify a 157 tooth flywheel versus a 164 tooth on small block Fords? So let's go over some of the features of this flywheel. Being that this is a 157, the way you can tell is on the ring gear face, the entire face of it, you can actually see from the friction side here of the flywheel. If you were to only see a portion of the ring gear, then you would have to slide the ring gear on from the opposite side. Being that the ring gear is slipped on from the friction side, we identify this as a 157. We don't need to count it. Ford, when they built these flywheels on the smaller 157, they had plenty of room to put the pressure plate bolts in. Ford, when they had stuck the 11-inch long pattern in on the flywheel, they had to slide the ring gear in from the opposing side to give the pressure plate more thread area so it was over the ring gear itself. So that's a quick way of knowing. If you're pulling a starter out and you're looking at the ring gear from the opposing side, you can see the entire face of it, you know it's a 164 tooth. And you have to have the matching bell housing and starter for a 164 tooth and a matching bell housing and block plate for a 157. Some of the other tech tips that we have for you today is this happens to be what we call a metric pattern. It's a 10.5, some people call it 10.4. It has these safety pins. There's 3 of them throughout the flywheel. That helps align the pressure plate to the flywheel. These pins are referred to as safety pins because they're stepped. When the pressure plate is on it, the 5/16 base versus a 1/4-inch stem actually can retain the pin from popping out. So some people call these alignment pins, some people call them safety pins. Their job is to align the pressure plate. Noted with this is 8mm pressure plate bolts. Okay, those only are going to fit in here. If you're trying to put a 5/16 threaded bolt, which is similar in diameter, don't make the mistake and send those in and bind them up and snap your bolts. Now this particular flywheel is a cast flywheel. The cast flywheel here has these Mallory holes. These holes are not drilled on purpose so that you can push weighted material in here to change the weight of this flywheel rather than continuing to take more weight off. Now this particular flywheel, which is not shown here, is a 50-ounce flywheel. It is important that you take and put the correct flywheel on for the motor that you're building or running. So in this day and age, original 289, 260s, 302s up to 1980 were 28-ounce in balance. Now this particular motor being a 5-liter, it still sports a 50-ounce imbalance. So that was introduced in 1981 and it was run all the way to 1995 on current 5-liter Mustangs. Now, and make sure they understand this is 5-liter HO and not Coyote. Modern DriveLine does offer a billet steel and cast 157 tooth flywheel where they would be dual drilled. So in these locations here, you would probably see something that is threaded with a shouldered area, recessed threads. So don't confuse the patterns. And if you are using a 10-inch long pattern, which was used prior to this 10.5-inch metric pattern, the pins are not used, they're pulled out, and then you would use only the 5/16 shouldered bolts in that case, okay? Other common questions that we get when I put flywheels on. You put a flywheel on, yeah, there are 5 holes here. People put the flywheel on and then we get a call in the shop that says, hey, my flywheel doesn't fit. And we say to them, have you rotated it? And then the common question we get back is, yes, or why is that important? Well, the flywheels, to keep the balance in line with the crank indexed, is that one of these bolts is about 40 thousandths out of center. So you have to keep spinning it until all of these bolts here, all 6 of them, are aligned with each other. Now this particular flywheel, I believe this index mark here indicates the hole that is out of center or out of compared to the other 5. So when you're putting a flywheel on, make sure that you spin it around, get all the holes to line up, and you're golden. That will allow the counterweight to be aligned with the crank every time. Other things that we get for questions in the shop. This one happens to be a needle bearing, commonly used from the mid-70s all the way up through, including your modular motors and V6s. A question that we get in the shop is when you put the pilot bushing, or in this case pilot bearing, in, the shoulder of this sits proud off the crank. That is normal. As long as you send it in carefully, you'll hear the tone change, and then you'll know that that is all the way in. Make sure that you do grease this needle bearing. If it's dry, use your pinky, put some grease on it, run it in there. Don't get excessive, but make sure that it's good and wet. Roll it around, that way it's good. The little blue seal that you see there is helping keeping the grease in. Pilot bushing, common question we get. Don't grease a pilot bushing. If it's oil light, it's impregnated with oil, you do not put anything on those bushings. You're going to push them in. A lot of times the bushing will go all the way in until it hits the shoulder, and then you know that it's all the way into the crank. If for some reason your crank is a little deeper, just make sure to put the bushing in so it's flush with the end of the crank lip. And at that point, you're basically done. So no material goes in there, no grease, no anti-seize, nothing goes in there. Crank bolts, common question that we get. What should I do here? Now, this particular car is not exhibiting. This car has been run, and we actually have pulled it apart here to show you some of this tech tip stuff. And you can see that it's dry. This is what we want. Do not put like never seize on these bolts, because that material can wick itself out, and the next thing you know, it's on the friction surface of the flywheel. So these bolts are actually going through the crank into a wet hole. It's not blind, it's actually open. So it is important to put probably like a blue Loctite, or if you got ARP, they provide some lubricant, a moly material. As long as we're keeping the oil from wicking through the threads and making its way onto the flywheel, we are good, okay? Other things that we get asked about. 85 foot-pounds of torque is typically used on these 7/16 20 type bolts. I believe they're 7/16, yes, I believe they're 20s. Commonly asked question. Which side of the clutch goes in if it's unlabeled? This particular clutch disc is unlabeled. As you can see, it's flat on one side, has a hub raised area on the other. The taller side goes towards the pressure plate, the flat side towards the flywheel, so that these springs can clear the flywheel bolts. As we're installing this, we're going to use an alignment tool. This particular one that I'm using is actually a cutoff of a broken input shaft from a T5. Works great because the plastic ones are not all that wonderful. They're made of plastic, there's a certain amount of tolerance to them, and we're just going to put that on there, shove it in until it bottoms out. Now, something worth noting here, as we're going to be careful with this, is that there's still, even with an input shaft, some movement. Now, if you have a plastic tool, if you don't have a tool, some people will use dowels, they'll use tape on the dowel to change the diameter. But really what you're after is to get this disc centered. If you allow it to hang here like this, as we're going to go put the pressure plate on next, this disc by nature is coming down, okay? So as we go to put the pressure plate in, we're going to take some time to make sure that the input shaft is going to be centered. So as we start to snug this up with a pressure plate on it, you're going to see me move this around, and at the end of the day, we need to be able to pull that input shaft out of this disc smoothly and easily, so that when we go to put the transmission in, we don't have the disc out of alignment and you're fighting it. Worth noting here, this pin is going to go into that hole, so we're going to want the pressure plate bolts going into here and here. So as we align this, we're going to bring it over the tool, Making sure we don't lose the disc in the process. Rotate this around. Get it started on the pins. And it looks like we have all three of them in alignment. Grab one of our pressure plate bolts, making sure not to let go of the pressure plate, otherwise it's a bad day. Just kind of get these started. Again, we're using 8mm pressure plate bolts in this particular application because we have those three alignment pins. Another little tech tip here is that we want to have access to the top bolts here. One of the things you can do is there's a tool that here is called a ring gear tool, and basically it clamps onto the ring gear itself and it allows you to hand crank the engine over from the backside rather than having somebody go into the front. So it's a handy tool. It allows you to bring that flywheel around, doesn't do any harm. You just want to make sure that you've got a good grip on the gear. And you know, it's not very difficult to rotate the engine over, and as you can see, I was struggling trying to get that bolt started because I really couldn't see it or get good access to it. So bringing it around makes that handy. It's worth noting here as I start to tighten up the pressure plate bolts on this clutch is that I'm at a point where I can still move this disc around. Hopefully you can see that in the camera. So with the steel alignment tool, I got better accuracy of centering. Now, when you draw the pressure plate down, you don't want to just send in the bolts one at a time. You're going to want to start tightening them around so that you're evenly bringing them down. If you ever get a point where you're drawing them down on one side, the fingers will go down in the center here. You're now causing the pressure plate undue stress. So it's best to bring this down together. And I'm just using a ratchet, and again, I'm watching what's going on, making sure that I've got even amount of threads. I'll get into a star pattern as we get into doing torquing. Alignment tool still doing well. Again, drawing all these bolts down evenly. Tension is starting to increase here, so I know that I'm getting closer to being to the end. At this point here, we can safely say we can remove the tool, give us some more room. Again, just hand tightening these up at this point. Now pressure is really being applied. We'll then start getting to a torque situation. Again, knowing that we have 6 of these bolts. And at this point, even from where I'm standing, the several bolts at the top are hard to see, so you're gonna have to do a feel for them. Again, starting to draw them down just a little bit. And right now I'm just kind of going to that point. Now, I'll break out the torque wrench. We're going to want to torque these up to 23 foot-pounds of torque on an 8mm bolt. Very similar on a 5/16. bolt as well. So don't want to over torque these. If you're having trouble sending them in, don't put an impact on these, you'll break them. Just poor practice. Always best to do this by hand. So where we're at now is that we've got the pressure plate bolts very close to being torqued up. So we've got our torque wrench set to 23 foot-pounds. We're going to do kind of a star pattern. Let it click over, grab another one. Go up and grab an opposing corner. Let's grab this one. One last one. Just double check, and I think we're good. So that basically gets your pressure plate and clutch in place. Obviously we had a nice clean surface here, so we were good to go. But if in case your flywheel or pressure plate had any residual film on it, make sure to hit some with some brake clean or solvent. That way that clutch is going to bed itself quickly and efficiently. One of the commonly asked questions we get in the shop is understanding what kind of clutch is needed for a particular clutch release. So if we're doing mechanical clutches like what you'd find in a 3 and a 4 speed, you would want to have a clutch designed for that application. In this particular instance here, we have a clutch that's designed for cable. Now, cable versus hydraulic, what is the difference? It has to do with the profile of the clutch. This particular clutch is lower and is designed for a clutch fork that is going to pivot from the opposing side instead of having it pivoting like this. So it's important that the clutch be shorter to allow the fork and throwout bearing to articulate this way, and so you cannot use a mechanical clutch linkage where we have the Z-bar and parts on the side for this particular clutch. Now here at Modern DriveLine we do offer this profile in a mechanical release, but we have to keep in mind that we have to make sure to not over push the fingers and that we have to have a taller bearing to overcome that. So in this particular application here on this 66 Mustang, we're doing an external slave, we're using a Fox body bell housing, and we want to use this cable release clutch. Now how can you tell whether it's cable or mechanical? The quickest way is to measure from these fingers here on the diaphragm to the friction surface of the flywheel. We would expect the cable clutch to be around about 1.6, 1.7 nominal, and that's a measurement from here to this friction surface, not down through the center of the clutch or the flywheel. In this particular application, the fingers are so low that we cannot measure to the fingers directly. Now I've got a straight edge here. The only way we're going to overcome this is to use a block like this of a known dimension. This happens to be a 1/2 inch. We know the ruler's about 80 to 85 thousandths. So what we're going to do to get down to the fingers here is that we're going to just put that block in there, elevating the straight edge over the top of the pressure plate. Now from here, knowing the thickness of our ruler here, I can take an engineering rule. This one happens to have a convenient little clip on it, and we're able to align this and just push down to the surface, and I get a number here. Now what we're going to do is subtract the thickness of the ruler and thickness of our block to know what our finger to friction surface is. Now knowing what that is tells us, okay, is this particular clutch a cable or versus hydraulic, mechanical? So in this case, we want this lower lever height to give us the room, as mentioned earlier, and this is also going to release faster than mechanical. A typical mechanical clutch, being taller, is going to release, let's say, at around 1/2 inch of actual bearing movement. This clutch is actually designed to be 250 1/4 inch to about 400 nominal. We guarantee our clutches to release at 375 thousandths or 3/8 of an inch. Now, with this, if our fingers come in, instead of the 1.6 to 1.7 that a cable clutch pressure plate is, if we had a measurement of 2.1 inches, then we know we've got a mechanical clutch, and that we know that that clutch is not going to work with our cable fork and Fox body bell housing. So you cannot intermix the mechanical pressure plate with the cable fork. So it's advised to change your clutch to this model, and everything then works together. Some would call it old school versus new school. So clearly what we're going for here is new school. We're going to install a Fox body bell housing with a cable Fox body fork, and then we're going to actuate it externally with an external slave cylinder. So now that you've seen how you can measure this, this is the technique that I would use to know what your finger height is. Now, what we're leading up to on this here is, as we move forward, we're going to put a bell housing on here, and we're going to check the placement of the fork relative to the fork opening. Now, as we go to put this together, it is important that we optimize the fork position in and out so that we are slightly behind parallel, meaning that as we are moving our fork in, okay, we don't want to be so far in, I'll exaggerate it, we don't want to start at this position and then have to push further inward. We want the fork to be leaning slightly backwards. Now the slightly is, ideally, is about 6/10 of an inch, because when we're half the distance of movement on our fork, we want it to be parallel. As we finish, we want to be 6/10 of an inch to be completely released. Now, why is these numbers important? The entire travel of this fork, okay, as it's actuating, is 1.2 inches. Now, how do we know that's important? Because we stated earlier, if we have 4/10 of an inch here at the bearing, the fork is a 3-to-1 ratio. Therefore, we're looking at 3 times that amount, or 1.2 inches. So ideally, we're looking for the fork to be here and then fully engaged, let's say, at a slight angle forward. So as we put the bell housing on, we want to pay attention to that, and depending on the height of the fingers of the clutch, each manufacturer, even 100 thousandths difference here, is going to affect the position by 300 thousandths or 3/10 of an inch. So as we move forward, we can compensate that a little bit. If you have, like say, an adjustable pivot stop, you can move the pivot point back here on the passenger side of the bell housing to make up for that. So it is important that we get the fork positioned, and in our example will be aluminum bell housing has a non-adjustable pivot. So how do we overcome that? We're going to look at making sure that a split washer is in there to start with, and if we have to, we'll add another split washer or a lock washer in there to change this relationship to make sure that we get it right before we stab the transmission in here. So let's go through that exercise. So what we have here is a I would say 79 to 1993 type bell housing. Now this particular one being a T5, T5s were first introduced in 83, so this was really an 83 to 1993 Fox body bell housing. Now the only reason I bring into that as being important is that you don't want to intermix a cable fork for a Fox body versus an SN95, which was introduced in 1994. The spacing is different. So what we're about to demonstrate here is the pivot is on the passenger side using this mushroom shaped pivot stud, and there's snap springs underneath this that are going to go up under the head of this spherical pivot. Now while we're here, let's talk briefly about the bearing that's included here. Now this bearing is specific to cable. You cannot intermix mechanical, which has a square back, with this round one. Now the round one snaps inside the spring here, or I should say the bearing has a collar, then it has the spring inside the collar, as opposed to the mechanical where the springs came in behind the fork. But in this particular case, what we're going after is inserting the fork, and we're going to check the positioning of the fork. And what we're going to do here is determine the height of this pivot stud in reference to the bell housing surface This particular one here from the factory should have a split washer down in here to set that height correct to the factory location. Being that the fork is a factory component, the only variable in this situation is the clutch fingers themselves. So when we go to install this, we want to install it and do that ahead of time. Now you can grease, this one has a little bit of light grease here. You can then add some more grease to the top of this. The only other place you want to put grease is in the collar to allow this bearing assembly to slide on the guide tube of the transmission. So we're going ahead and insert this, being careful to get the springs underneath and in place. So we want to make sure as we insert it that we don't get the springs go sideways. So I'm going to turn the bell housing to make this just a little easier. And if you have to, you can put a screwdriver or a finger on this to snap it in place. And it's in place. We can verify that the springs are up underneath and not on the side. This one happened to be the right side here was a little off, so we now have the proper pivot, and that's how it's going to move. So to demonstrate more in detail, if we have the fork slammed all the way to the front, then we have no more room and we're going to run out of travel. Now if you try to intermix a mechanical clutch into the equation where the fingers are taller, it's going to naturally push this fork all the way back. So if you put this together and you naturally see that the fork is slammed all the way to the back, you know you're in trouble and you should stop at that point and get yourself another clutch. Now at Modern DriveLine, we have a complete line of superior clutches, and we can help you through this and pick out the right clutch for you based on the friction and horsepower that you're running and the driving style that you're desiring. So we're going to go ahead and move forward with this, and we're going to make sure that this is correct. We know from pulling it apart that the fork was too far forward, so we already know that in our case, we're going to have to take the pivot out, add another split washer to bring this fork back just a little bit more to optimize it. So using a 7/8 wrench or socket, you should be able to unscrew this pivot stud from the bell housing. So we're going to go ahead and get that off. Now behind it is nothing more than a 1/2" 13 thread. So again, all we're going to do is add another split washer, making this assembly a little taller. So all we're going to do here is we're going to grab another split washer. We can just kind of stack them up, and we still have plenty of threads to engage it back into the aluminum casting. Again, if this was a QuickTime or a McLeod or a Lakewood bell housing that had an adjustable pivot, then that could be reestablished and the jam nut tightened up. On our website, we do call out for what the stock dimension is, so look in our tech area for further details. So now that we have that good and tight, we're going to go ahead and reinsert this here and get this snap back in place. Again, double checking to make sure that that spring is where it belongs, up underneath the head. And just turn it around here to get a better view. And the top one here is not completely snapped in. Okay, we're going to take the screwdriver here, just push down on that spring, making sure that it's snapped underneath. And now that it is, you'll find that the fork is balanced. It doesn't want to pull to one side. And it's careful because some of these can actually be very brittle, especially the aftermarket ones. The Ford units were a little better on the springs. So now that we have that in place, we're going to go ahead and install this. As I mentioned earlier, this is a cable style. Cables typically had a bell housing like this here, where the cable came in from the front. The cable then would pull forward like so. With our hydraulic system, we've retrofitted this bell housing with 2 holes. Brackets is mounted on the inside of the bell here, and we're going to create a pushing action using a slave cylinder from behind. Let's talk a moment about starters for a small block Ford. Now the one I have in front of us here is a 157 tooth starter, and it's a gear reduction starter, or a solenoid that's built onto the side of it. And being a step reduction starter, it has the solenoid built in. Now normally on a small block Ford, especially the early ones, didn't have a solenoid and it was a direct drive. Earlier ones had larger motors, the 5 liters from, let's say, the early 80s and all the way maybe to the late 80s were also just a one drive, no solenoid on the side. The motors were slightly smaller. Now when working on these cars, you can choose pretty much any starter that meets your needs as long as the power is there enough to spin the motor over comfortably. Now the advantage of the step motors like this is a high torque step motor is its size. Clearly it has the capability of turning over a higher compression engine. But when we're doing conversions, it's important to match your starter configuration. In other words, we spoke earlier in the video that a 157 tooth starter has to be used with a 157 tooth bell housing and flywheel. Now, how do you know if you have one? Well, the registration here in the front is a very specific size. So if you find the starter will not go into your block plate and you had originally a 164 tooth starter, don't enlarge the hole. You have the wrong starter. There is no such thing as an automatic versus manual starter. These particular starters, again, are based on the position of the pinion gear and the diameter of this starter snout. Now, what's also important is the position of the starter, the snout and the gear. Now, sometimes when you read in the technical manuals or online, sometimes these starters are referenced as to be a 3/8 versus a 3/4 offset. Now, as I mentioned before, in a flywheel, the ring gear on a 157 tooth is closer towards the friction surface by 3/8 of an inch. That's important because if I were to try to install a 164 tooth starter on a 153 tooth or 157 tooth ring gear, even if you were to make it fit with an incorrect bell housing or enlarging the hole, the gear would never engage because that ring gear is too far out. Okay, so it's important both in offset and also position of the gear. Okay, so if you have a C4 automatic, or let's say an AOD, and you're converting to, let's say, a T5 or a TKX or even a new Magnum, you would want to make sure that these components are matched together. So what we have here clearly is a 157 tooth. We know that the offset's going to reach out there with a 3/4 inch offset. We have the right ring gear, so this is going to be naturally a great fit for a Fox body bell housing or even an aftermarket bell housing as well, as long as it's 157. Want to make a quick mention of this block plate. People sometimes wonder, is it necessary? Can I use the one I had from the automatic or a 4-speed? No. The registration of the plate is absolutely necessary for the starter on this side here. So on Fords, the plate is picking up the pins of the back of the block, so the plate is the registration, and of course the starter picks it up from here. So if you leave this off and think you can get away with just 2 bolts on this side, no, you cannot. This plate is crucial. Now with this plate is sized for the T5 or TKO/TKX bell housing, so this plate is critical in that nature. So the shape of it, the bolts here at the bottom, are all going to enclose this. Now, if one was in a very desperate situation, could you use a plate as long as it's a 157 tooth? You could, but the registration and the shape of it in the bottom is not going to match. So clearly we have the right plate, and we're about to put the bell housing in place. So with our headers in place here, these are long tube, kind of a tri-Y setup. Getting the bell housing in is going to be a little trick, so we're going to turn it a little bit on an angle, get it to slide in, and we're in. So we're going to drop this in on the pins on the block. I'm going to one side, and we're on to the other side. So we're going to go ahead and insert our bolts. There are 2 different lengths on this. 4 of them are going to be longer. 2 of them are going to be shorter. We're going to go ahead and insert our longer of the bolts first. The bosses on these aluminum castings, there's 4 of them that are taller. 2 of them at the top are shorter. Now, if you're doing a T5, by the way, these bolts on the back are metric, whereas the engine side is fractional. So beware of that on aluminum bell housings. If you happen to have an aftermarket one, that may be different. I think the Lakewood product does not distinguish between metric and standard. But on these factory aluminum bell housings from Tremec / Ford, they are definitely metric on the back side. Now, these 2 top bolts are way at the top of the bell housing. Not exactly the easiest to get to. Might be easier to use it with an extension. All right, get the next one in. So it's worth noting that this hole you're seeing here in the trans tunnel behind the engine is where the original 4-speed speedometer cable would have exited through for a 4-speed car only. On a 3-speed car, that connection, whether it's 3-speed manual or 3-speed automatic, is actually on this location. So when you do these conversions, you're going to take a 20-inch shorter cable, roughly 60 inches long, and you're going to run the cable through this hole. Now, this hole here should be plugged so that you don't get anything going through it and get any weather or whatever. So that is a natural hole for the 4-speed. I know that we mention this often in our videos, but I cannot stress enough how important this bell housing being centered to the crank it needs to be. Now, this is what the transmission centers itself on. It is not the bolts out here. So when the transmission with the bearing retainer comes in, this is a very critical area. So you want to make sure this is clean, this is free of burrs, it's not egg-shaped, it's not wallowed out. And you want to make sure that you do a bell housing dial indication. I'm not going to demonstrate it here in this video, but I want to make sure that you take the time, put the bell housing on without the clutch in place, just the flywheel, check your bell housing, a run out, start the 12 o'clock position, hand crank the engine, and just check to make sure that you're within 5 thousandths of an inch or less. Keep in mind when you're reading your dial, you're actually reading the sweep of the diameter. So you're always going to take your reading, divide it by 2. So if you get 10, you're actually only 5 out of center, meaning that you're in spec. So important to do that. So let's get on to checking the fork placement. We added the extra washer under the pivot stud, so we want to verify, see how the fork is doing. So we're going to reset the cameras and come in onto the side to give you a better view. What we have here is the cable fork on the Fox body bell housing. Right now the transmission's not in it, so the fork is drooping. It's not normally it would be centered here. But what we're trying to show here is the position of the fork. We are not, if we had a mechanical clutch, this fork would be slammed absolutely to the back. In fact, we would probably even had trouble putting the bell housing on because of the interference with the pressure plate. And so what we have now is, if we push the clutch lever or fork forward, we can see that the positioning of the fork is about 2/3 of the way back in the opening, and that's what we're looking for. If we were half or maybe only 1/3 of the way back from the front to the back, then I would be concerned and I would stop and I would go into the pivot here and make an adjustment. Now, if we had a QuickTime bell housing with a adjustable pivot, before we've installed the transmission, we could loosen the jam nut, make that adjustment without even taking this apart, and then get it optimized for what we want to do. So again, what we're looking for is the fork to be about 6/10 of an inch from being parallel with the flywheel. As we push the clutch in, it's going to be 6/10 of an inch on the other side of the center line of motion. So as long as we've got proper positioning, we can proceed forward with the rest of the installation. What we have here is a Ford T5 Tremec transmission, and I want to point out a couple of features of this transmission. A lot of people ask us, because there's such history with the T5. T5 is the longest running manual transmission in production, superseding top loaders and Muncies. They've been produced since the early 80s and have evolved over the years. What we have is what we would call a T5Z. The Z is a designation from Ford when they sold the Super Duty T5. So this is a Super Duty T5 Z. It's a world class. So on this transmission, the way you can tell world class is this lower cluster bearing cap. If you can read the name Timken, it doesn't look like the back end of a freeze plug. The back end of a freeze plug would indicate it's a non-world class T5. And no, you cannot upgrade a non-world class to world class, which is a common question we get. The other thing that the T5Z benefit from is the upgraded metal bearing retainer guide tube. The production ones all the way up through probably about 1992-93 on the GTs only had aluminum bearing retainers. So if you have an older unit, here at Modern DriveLine we do sell upgrade parts, and this is one of them. So this is a commonly upgraded piece. So great for when you don't have to have the throwout bearing hanging up or wearing on that aluminum worn out bearing retainer guide tube. The other thing that's important to know here is there's a bit of a shiny mark on this particular input shaft. The reason I want to note that is that we know that this pilot tip is engaging properly with the pilot bearing or bushing. If there were no marks here whatsoever, it's a telltale sign that this input shaft is not properly supported by the crank. So you want to make sure that that's happening. In this case, we've got a good ½ inch of engagement here. The other thing to note while we're looking at this is T5 has evolved over the years. So for the Fox body, we have a 7.2 inch shaft. So that means that we're 7.2 from end of shaft to the main case. So that's what we're wanting to use here in this classic Mustang. If you happen to have one that is 7 7/8 long, 5/8 of an inch longer than this one, you have an SN95 shaft. And that is clearly indicated just by measuring the length. Now everything else will look similar. The bearing retainer will also be a little bit longer to match the length of the input shaft. The difference being is that the SN95 had a deeper belt due to stretching of the chassis drivetrain in those cars. So in this particular case, we're working with the Fox, so we have a Fox bell to match. Now, if you happen to have one of these SN95 transmissions and you're wanting to put it in behind a Fox bell, we do sell a spacer plate to make up for it. And we can also sell you a shorter shaft and bearing retainer. So contact one of us in sales or tech. We'll be glad to help you with that. The other thing worth noting here is one of the commonly asked questions we get is, how can you tell a V8 transmission from a 4-cylinder one in a Fox body platform? Pilot tip is a dead giveaway. So if you're looking at the pilot tip, all the V8s had a 670 pilot shaft diameter. If you're looking at a 590 thousandths, clearly 4-cylinder. So if you're putting this behind a V8, stay away from the 4 cylinders. They're just not geared right and the torque rating isn't there. One of the common things that we see on the tech line is that when these transmissions are shipped by ground, they're in a container, they're not on a pallet, so therefore they tend to take a little bit of a tumble. And we get folks calling us on the tech line saying that the transmission seems to be stuck in gear, and they discover this after they've already installed it. So I highly recommend that you take the time, row through the gears, check to make sure that you're able to get into all gears, spin the input shaft while you're doing it so that the synchronizers and the slide rings have an opportunity to mechanically move. Now, let's say for any reason you have a TKX transmission, those seem to be more problematic in the area of bumping into gear while being shipped because it takes a shock, and one of the forks and slide rings will be stuck in typically third gears. What we see most of the time is to verify that you're able to shift through all the gears. And if for any reason you're not getting into all gears, give us a ring. We'll walk you through how to unlock it. It's actually a pretty simple process on the TKX. There's a cover here in the about this location. It can be removed, and then you can pop it back into neutral, and then you're able to move it through. There's no harm in it. You just have to pop that cover off, and now's the time to do it, not when you've got it in the car and you have no access to it, and then you become frustrated after we give you that information. So again, we don't have a shift lever on here, but just make sure that you're able to move it through its gears and get into every gear, including reverse. So a couple other things that we commonly get questions on too, I'm going to turn the unit around, is this switch here. This switch is commonly referred to as a neutral safety switch. This switch is only used for cruise control shutoff. In the Fox bodies, if you had it in a cruise control and you were engaged, and if you were to pop it out of gear, the cruise control is disabled. So when we call it a neutral safety switch, cruise control, it is not designed as a start circuit. The rating of the switch is not meant for that. My suggestion, if you're looking for a neutral safety switch on the clutch pedal for start interlock, engage one on the pedal, and then check with us later this year. We're going to be offering a clutch interlock product for both the stock pedal and some other products that we will be coming out with. The other thing that I can mention while we're here, we have a Speedo, or not Speedo, but the reverse switch, pigtail that can snap onto this. This is where your reverse is. You have a Speedo gear location here next to where the cross member is, so a cable can go directly in there. If you're using a electronic signal, we have VSS, vehicle speed sensors, both analog and digital, that can be slid in there to accommodate your needs depending on your speedometer. So just let our sales staff know which one you're going to use, and we can certainly help you there. Just that easy. All right, we have installed the T5 into the 66 Mustang here, and we're wrapping up with some of the technical pieces of this. And we want to go over the shift fork slave cylinder setup. Now, you may have remembered earlier in the video that we added a split washer underneath the pivot stud to bring this fork back. We had noted earlier that the fork was too far forward with the stack of the clutch and the throwout bearing. Now this fork is pushed all the way forward so the bearing is touching the fingers without any pressure. We've installed the slave cylinder, made the adjustment on the adjustment nut with a locking nut behind it. We do never put the locking jam nut ahead of it. It's worth noting now that we have this together that the fork, from the back edge of the fork to the back edge of this T5 aluminum Fox body bell housing, is only an inch of space between those 2 points. It's important because this is where we want the fork to start out. We got the proper adjustment of the push rod. We've got plenty of thread engagement for our socket that was added to the fork. We've got plenty of room between the front of the fork and the fork opening. This will allow for the proper geometry for the fork so that when we swing this fork 1.2 inches, that we're roughly 6/10 of an inch behind midline of how this is going to move. So in an ideal world, we want the fork at half travel to be parallel to the flywheel. So we're in really good adjustment here. We have already purged the slave cylinder. There's going to be a separate video on that if you would like to know how to purge the system using our one-man bleeder kit. And then we have the bleeder port at the back of the unit. We have vent lines and so forth that are shown in that video. So make sure to check that video out. But now that we have the proper adjustment and we have proper bleeding, when you push on the pedal of the slave cylinder, one of the commonly asked questions is, how do I know I got all the air out? It's because when you push on the pedal, the slave cylinder is going to immediately move. Hydraulic fluid or fluids are a non-compressible media, so if we have a bubble that's in the line that didn't come out, then that slave cylinder is delayed in moving. So that is a key question that we ask and a key question that we want a response to, that if there's a delay, let's say the pedal goes down 3/4 of an inch to an inch and there's nothing moving, clearly we have air in the system. So that's key in that particular question, so that you know that it's not an adjustment down here. Once you've done your mechanical adjustment, you really shouldn't be messing with this any further. But what is important when you do make an adjustment here is that when you push the push rod into the housing here, is that we want to be able to push this thing back and see that it doesn't collapse. If we have a collapse movement of the piston, there is a little spring inside here, and that piston may be arbitrarily or artificially forward where we don't want it. That is key, because if we allow the piston to be further forward, and we've done the adjustment here, even though we're up against the bearing, when we go to actuate this, the piston will leave the housing, causing you a leak or the piston to bind up and be hung up. And then you have to figure out how to fix it on the side of the road, or you're towing it home and you're not happy. So let's make sure the piston's at the beginning of the stroke. We use 1.2 out of a possible 1.3, so the piston should never leave the bore normally. You can always check this underneath the boot. You can just peel this back, and when you extend it, the piston should not be flush with the housing. It should be somewhat recessed. So that's another way of validating that, okay? So when we also are moving the cylinder up above, we have 1.4 inches of master cylinder travel, and we're getting 1.2 here. Now, why is 1.2 so important? The bell housing is a fork with a 3-to-1 ratio. The bearing inside is a 0.4 travel. So you multiply 0.4 times 3 leaves us with 1.2, and we know that we should have a proper clutch release. Clutches in the industry for a cable release will guarantee to be released at 0.4 or sooner. So you should have some over travel when you modulate the pedal on the floor to give you the full release. So we've designed it for maximum leverage, minimal amount of pedal effort, and that way you get a smooth, controlled movement of your hydraulic system, hence our Lightfoot series. So that is basically the adjustment and a lot of the commonly asked questions that we get here with the system. Now, I have people who will say, well, I've got a steady stream of fluid coming out. However, they're not getting enough velocity. They'll try to do pedal bleeding, vacuum bleeding. None of those techniques work. The key part in getting the system bled is to insert our one-man bleeder kit right into the reservoir, squirt that material right through the port all the way down. You want high velocity to get the bubble to burp out. If that bubble is going from high to low, it wants to travel back up the line, and you can play this game all day long. So while you may see a steady stream coming out, it's key to get the velocity. Do it 2 or 3 times, and once you've burped that bubble out, you will get a firm, controlled pedal every time. So I hope this was helpful. If you need any further help, contact us at moderndriveline.com or on the tech line at 208-453-9800. And thank you for visiting with Modern Driveline. Another quick question that we get in the shop all the time is, what type of oil do I put in my T5 or Tremec transmission product? We happen to have here a world-class T5 and a 66 Mustang. So world-class T5s use a Dextron 3 ATF, automatic transmission fluid. Yes, you heard correctly, automatic transmission fluid. Now, as long as it's a Dextron 3, we're good with putting that in a world-class transmission. We do not recommend other fluids. The reason for it is the synchro inside the transmission have friction that are made out of carbon material. That carbon material needs a friction modifier to do the grip and release of the transmission synchronizer. So what we have and what we recommend is an Amsoil synthetic product called ATF, and you could use your favorite, whether it's a Mobile One or others, as long as you're using a Dextron 3 product and not some other Dextron 5 or some other thing. Dextron 3 is the go-to oil for this transmission. Non-world class transmissions, however, were designed to use Dextron 2. The difference being is that it's a thicker oil. Dextron 2 is not available any longer, so the best what we can do is use a straight 50 weight oil in the transmission. Now, why is it different? It's different because the synchronizers are different and the construction of the main shaft is different. The main shaft in a non-oil class has no needle bearings. It's relying on a higher viscosity oil to roll the gear over the main shaft. And in doing so, it allows for the oil to get in there. Now in a world class, we have needle bearings, and so the viscosity of the oil is about a 30 weight oil, give or take. So on this T5, the fill and drain plugs are on the passenger side of the car, or the transmission right-hand side. Do not mistake any plug you see on the left-hand side as a fill plug. Only on the left or right-hand side are there some national pipe thread type plugs. It uses just a 3/8 drive. So if you want to drain it, you would simply put the socket in here, back the plug out, and service it that way. This transmission is dry. We don't have any oil in it. It's been drained already. So we're going to go ahead and fill this transmission, and directly above there is a similar plug that we have to loosen. So we're going to make sure we're in a counterclockwise direction. We don't want to over tighten any of these plugs because it could crack the case. So these are tapered normally. So if you're having a problem with the plugs leaking, always recommend reapplying a Teflon or type of plumber's sealant on this, and that will help it seal it. So don't over tighten, especially the drain plug. Again, the plug kind of looks like this here. Again, tapered, and it just, as you can see on this one here, there's not much sealant left on it from being taken out from a previous service. So we have the fortunate luxury of a device here that is pressurized. We'll be able to squirt this material in using pressurized material or ATF. But if you are at home and do not have a means to pour it in, I recommend going down to your local auto parts store. For about $10, you can buy a little quart a pump, and it just goes into the container, squirt, squirt. Easier to have maybe a little station next to you so you can push on it while you hold the hose into the hole. The goal here is to get about 2.75 quarts into the transmission until it's level with the bottom of this fill plug here. You don't want to overfill it. Way you can also check is if you take your pinky, run it into the hole, and see if there's oil on the other side of the threads. If you're low and you cannot feel the oil, I recommend topping off for whatever reason if you have not enough oil in there. You want to make sure the transmission is level, of course. You don't want it sitting on an angle and have artificial reading. So we're going to fill it in a natural state. I've had customers ask me on the tech line, can I fill the transmission through the shifter opening? If you have the shifter off, for some reason you wish to pour it in. Yes, you can, but you just have to be careful that you have the plug removed and you know how much oil is in the transmission. And when you are pouring it through the shift box opening, keep in mind that the hole in the bottom of the shift box is only so large, and you'll have to be metering your oil being poured in so that you don't overcome and spill over the edge of the case. So we're going to go ahead. We've got this thing pressurized. We got the AMSOIL ATF. We're going to take our line here, feed it into the hole of the transmission. We're going to make sure that it's inserted far enough so you don't get an artificial feedback of the oil dripping out. We have it pressurized to about 30 psi. This light viscosity oil won't take much, so we're going to meter how much oil is coming in so that we don't do it too quickly. I do recommend that we change the oil in a transmission, you know, more frequently than we like to admit. Frequency depends on usage and your environment in which you're running the car. If you're running the car hard in an open track environment, I would definitely recommend changing it seasonally. Oil is cheap, transmissions are not, and we have reached full. So we have going to be pulling back the line here. And we are full. Okay, so I quickly put the plug in because with our fast fill system, we were getting some oil coming out of the hole. That's one of the downsides. You have to really kind of pay attention because, yeah, it's convenient. It moves it fast, but it also will come out there pretty quick, so you'd be on your guard. As I mentioned earlier, we are using here a Permatex thread sealant with PTFE in it. So we have a fairly large container of it, but it comes in squeeze bottles and much smaller paste. The consistency of this product is basically a white pasty material. You just apply enough to seal it on the threads, and that will stay in a kind of a pasty condition. If you're in a jam, you probably could use an RTV type product. Basically, you're just trying to seal those threads from allowing oil to wick out of the plug. So that's basically it. Again, don't recommend gear oil in these transmissions, much too thick. We like to think that it's a manual shift transmission. We put gear oil in them. Those are left for the top loaders and the 3 speeds of the day. The T5 using a lighter viscosity works better in colder weather and warmer temps. Again, a good synthetic brand will service you well. Break-in period with transmissions. T5, you could put a regular standard Dextron 3 oil in, let it run for a couple thousand miles, pull it back out, and then you can put the AMSOIL ATF. And if there's any other questions, give us a ring on the tech line. All of our TKXs and T56s and Magnums, again, all use a Dextron 3 oil, your 45s, 3650s. So keep that in mind. But if any of those transmissions that I didn't list and you have a question on it, give us a ring. We'll be glad to help you at moderndriveline.com and tech@moderndriveline.com for an email address, phone number 208-453-9800, and thank you for making it modern.